Okay, good morning. My name is Jungsoo Kim from SK Telecom. I'm an R&D manager in Software R&D Center. So today, I'd like to talk about hardware monitoring and management system for telco data center. So I'm going to go briefly talk about the next generation infrastructure in telco data center and why we developed the hardware management system. And I will go over objectives and architecture, and I would like to show some demos today. Okay, so last year I talked about the evolution of telco data center and networks from 2G, 3G to 5G. One of the key characteristics of next generation data center is mobile network and data center are converging. And the diverse applications like OTT, media service, SNS, or telco application for LTE, 5G, and IoT, or enterprise services like OSS, BSS will run on same virtual resources and physical resources. And the infrastructure is software-defined, so there is a software-defined compute, software-defined network, and software-defined storage. And another characteristic of next generation infrastructure is it will be open hardware and software-based. So when it says open hardware, it doesn't need to be only open source hardware like OCP server, but off-the-shelf commodity server, which supports standard protocol or interface, will be used for our infrastructure. So NFV and MEC are one of the building blocks of 5G infrastructure. So the requirements of infrastructure management system is they should support physical and virtual resources. If you look at the SK Telecom's virtual infra manager reference architecture, there is a virtual resources which use OpenStack and Kubernetes, and there will be multiple vendors solutions. Also, the hardware, there will be multiple vendor hardware and open source hardware. So the new infrastructure management system should support vendor neutral system, and because there are so many layers, the infrastructure is very complicated. It should provide automated and intelligent functions to the user. So we wanted to expand infra management scope of existing system by having more detailed hardware information and by provide in-band and out-of-band management network, and by having a unified monitoring system, and we want to fully automate hardware management. So there are some objectives of HMS system. So we want to have a deep knowledge of data center hardware components. For example, the asset data. There are a lot of components in the system, but I saw many cases we don't use such information to manage the infrastructure. So, for example, memory, you can pull. There's information about the memory location, like the form factor, or asset tag, or serial number manufacturer, or GPU, and NIC card is the same, the RAID controller. Also, we want to collect the sensor data, like the inlet and outlet temperature of each node, or power, and so on. And we want to automate the change management and asset registers. So by automatically detecting any hardware changes or system configuration changes, we want to, the operator can notice any changes in our infrastructure. Also, I saw many cases that engineer makes mistakes when they enter the serial number MAC address manually in the system. So we want to collect those all the system information automatically and provide the machine-generated code to the database. And the system should support vendor neutral system, both off-the-shelf system and open source hardware also. And the system should also flexible. So as the technology changes so fast, our infrastructure also changes fast. And our hardware components like GPU, accelerator card, we need to monitor those hardware components. Because the GPU consumes a lot of power, it sometimes generates a problem to our data center. So this shows how we can automate our hardware management, hardware life cycle management by having HMS system. So once we purchase the system, vendor will submit the requirement document to operation, and operation will issue a ticket. And the vendor will come to our IDC that will install the hardware, and operation will install OS and applications. So at this point, when OS is installed, HMS agent will collect hardware data and sends the data to the database automatically. And after that, operator can review the list of hardware that is installed. And once he confirms, the CMDB or AssetDB will be updated. The change management is, and HMS can detect any hardware changes. It periodically checks all the value and new value. And if there is a difference, it notifies to the operator so that the operator can notice any unscheduled changes of the hardware system. So this is the high-level architecture of HMS. On the top of the layer, there's application layer, and there's a resource analytics. Resource analytics is compiled, collected data and provides some simple stats to the user. And there's a cluster manager. It manages cluster of the nodes. And agent manager, it checks the hash stats of the agent so that the system can notice any agent failure. And also there's a change manager, which periodically checks any changes in hardware. And we use two different kind of database in our system. One is the relational database, which stores any statistical data. And the other one is the time series DB. So all the metrics that we collect is stored to time series DB, and the asset information like a serial number or asset tag also stored in the time series DB. So we think that it's very powerful to save your asset data to time series DB because you can track your history of hardware very easily with. And in the middle of the layer, there's a telemetry framework, and it has the RESTful architecture. And it offers computation module and network module and storage module, which collect each compute and network storage data. So to develop HMS, we used open source software. For development of backend, we use Spring Boot. Spring Boot is a lightweight version of Spring, which is most popular backend development framework. For front-end development, we use the AngularJS, Java library. And for relational database, we used MariaDB. And for time series, we used InfluxDB. The reason we chose InfluxDB is it supports SQL, SQL-like query, which is very useful when you query your statistical data from the time series database. On the middle of the layer, there's a telemetry framework. We use Snap. Snap is developed and open sourced by Intel in 2015. And I will go over more details of Snap on next slide. And there is also, there's a Puppet-less factor utility. We don't use Puppet-less agent to control our process, but we only use Puppet-less factor utility to collect facts, which is the system information of the server. And for dashboard, we used Grafana, which is one of the most popular application. So I'd like to briefly introduce the Snap, and I'd like to talk about why we chose Snap to implement our hardware management system. So Snap has very flexible architecture. It has the plugin architecture, which means the collection of data, the processing of data, and publishing of data is all done by each plugins. So you can configure your application very according to your needs. For example, if you just need to collect and publish two data of the system, you just need two plugins, a collector plugin, publisher plugin. But if you need different destination, and if you want to send one data to dashboard and send the same data to analytical system, you can have two publisher plugins. So Snap has very flexible architecture, and it has RESTful support. So that's why we chose Snap. Also, it has decentralized architecture. So in the legacy system, to control your monitoring agent, there is a central control server. And if you want to configure agent, the main control server will send the file to every node in your cluster. But with the Snap, there's no central server to control. So if you send any plugins or task files or configuration file, one of the node in the cluster, then the Snap takes care of rest of the task. So it automatically copies all the plugins or configurations and task files. So Snap has the plugin architecture. We use 6 plugins for current system. And 2 of them are the open source plugin, and we developed 4 plugins to use. So on the collector side, there's a factor plugin which collects system information, and it collects over 200 matrices from a single physical node. And with the hardware component plugin collects DMI code information like memory module, location, asset tag, serial number, and so on. And it collects PCI devices information and disk drive smart data. And it collects about over 510 matrices. We also developed IPMI plugin, which collects IPMI specific information like a BMC, firmware version, and inlet outlet temperature, fan speed, and it collects about 30 matrices. And since the HMS system is used for AI cluster which use GPU a lot, we also developed SMI plugin. SMI is the NVIDIA utility which provides GPU information. And we also developed the processor plugin to tag custom data to every custom data. So this is the main page of HMS system. On the top of the main page, you can see simple stats of the cluster. There are 130 nodes, and there's agent status. 5 agents are dead, and there are change status. So whenever changes in system occurs, the system show you the number of changes occurred in the system. And on the bottom side, there's a group list. You can add and remove new groups. And there's a node list. If you click the node list, you can see all the metrics that the system collects. And on the group management menu, there are task management, plugin management, and node management. So you can basically add same group nodes make the same group, and which has same task and same plugin, and you can manage tasks files and plugin files in the group menu. And there's a plugin management menu, and you can load, register plugin, or you can remove the plugin from the system. And the HMS also offers a task management. So task is the configuration file where you can set the collection interval or the item that you want to collect, the metrics list. Also, you can define plugins that you want to use. So you can edit the task file, and if you want to use the task from to your managed node, you must first make any task file first. And also there is a change in management menu. You can, whenever it changes, system notifies to the operator, and you can check what changes in your system. In this example, because there's no old value list, the reason is that this is a new system that newly installed system, there's no old value. So it only has the new value that collected. So this is a dashboard made with Grafana. It took only a couple of hours to make this kind of dashboard with HMS system. It shows some statistical information on top of the page. On the middle of the graph is distribution of inlet and outlet temperature of our cluster. So you can see that the left side is inlet temperature, and right side is the outlet temperature. On the bottom, there's a square boxes, which is green. Some are the orange. And it represents each node of the cluster. So in this case, it has about 130 square boxes at the bottom. So if you click the box, you can see detailed information of each node. So there is a host name, model name, and process name, number of core, number of memory, and number of disk, the name, model name of the radio controller. So all the information here are collected by the agent. So there's no input by the person. And you can draw also the graph of power consumption and inlet and outlet temperature and fan speed. Since this is a GPU server, it uses GPU plugin that we developed. And it offers a detailed information of a GPU. So you can have, it has a model name of GPU, the utilization and temperature, and you can draw the graph of the GPUs. So I'd like to show you a very simple demo that which uses SDV application that we developed. And the SDV is the application that offers 3D view of our data center. And the application uses IPMI data to display inlet and outlet temperature in real time. So this is the low of Rex. And you can see that a little temperature changes on the left side. Because this is inlet temperature, there are slight temperature differences. Yeah, so zoom in. Mm-hmm. So this is the rear side. So the color is more red than inlet front side, because this is outlet temperature is hotter than front panels. So you see the temperature changes over time. So we could integrate our HMS system with our 3D view application and dashboard application easily. So for the future work, we want to support multi-data centers and multi-rooms. And we will integrate our hardware management system with NFV and MAC infrastructure management system. And we will support next generation protocols like Redfish or OpenConfig for network switch. And we also expand our data coverage to enterprise storage also. And the HMS system can also, there's a possibility that we can integrate our HMS with facility management system of a data center. And lastly, we want to also open our developed plugins to the community. Right, thank you very much. If you have any questions, please feel free to email me, or we can talk here. And I have a quick notice. We have another upcoming talk from SK Telecom at 11 a.m. Please come and join our another session. Thank you very much.